Okay, so now we are in chapter 3.1 and we're graphing linear equations in two variables. Our first objective is to plot ordered pairs in the rectangular coordinate system. So it starts off by saying, in the rectangular coordinate system, the horizontal line is the x-axis, the vertical line is the y-axis, the point of intersection between these two axes is called the origin, and the axis divides the plane into four regions. So horizontal line is your x-axis, the vertical line is your y-axis, so we know x goes left to right, y goes up and down, and in the middle where they meet is the origin, and it's the point 0, 0. Values to the left of the origin would be negative for x, and then values to the right would be positive. Values above the origin would be positive for y, and values below would be negative for y. The plane is split up into four quadrants. So you start here with positive, positive, and that is quadrant 1. And then over into second quadrant, it is negative, positive. The third is negative, negative. And the fourth is positive, negative. We write a point as x, y. So for example, in the first quadrant, the x is positive and the y is positive. So that's how I have positive, positive. In the second, the x would be negative and the y would be positive. So that's how you get negative, positive, and etc. Okay, so each point in the rectangular coordinate system corresponds to an ordered pair of real numbers x, y. You always write it in alphabetical order, x, y. Note that the word order, because order does matter. So for example, down here, this is the point 3, 5. That means the x is 3 and the y is 5. So you would move over 3 units to the right and 5 units up if you started from the origin. The next one says 4, negative 3. So the x is 4, so 4 units to the right, and the y is negative 3, so down 3 units. If you were to switch the order, so for example, if I had the point 5, 3, well now the x is 5 and the y is 3, so that means 5 units to the right and 3 units up. So you see the difference between 5, 3 and 3, 5. Alright, so practice. Let's plot the following points. So it says A is negative 2, 4. So that means x is negative 2 and y is 4. So starting at the origin, I know I'm going to go 2 units to the left for the x. And before you make your point, go ahead and do what y says. So y says 4 units up. And that's my point, A. And then for B, we have 4, negative 2. So starting at the origin, we're going to go 4 to the right and then 2 down. And that is the point B. And we're filling C, negative 3, 0. Well, now x is negative 3, so 3 to the left. And y is 0, which means do not go up and do not go down. Stay exactly where you're at. And then D is 0, negative 3. So this time the x is 0, so we still are here at the origin. And then negative 3 is y, so we go down 3. Okay, so let's move forward. So objective 2 is now to find the coordinates of points in the rectangular coordinate system. So we can plot the points. Now we have to make sure we can identify them. So it says determine the coordinates of points E, F, and G. Well, I know a point can be written as x, y. So the x comes first. So when I look for E, I'm going to start at the origin. And I see I have to go 1, 2, 3, 4, 4 to the left. So the x is -4. And then we go 1, 2 down. So the y is -2. Do the same thing for F, and it's 2 to the left. So -2 for x. And since we stayed here, we did not go up or down, the y is 0. And then the last point is G. So we got 1, 2, 3, 4, 5, 6 points. 6 units to the right. So x is +6. And then we stay there, so y is 0. All right, objective 3 says determine whether an ordered pair is a solution of an equation. So it says the graph of an equation in two variables is a set of points whose coordinates satisfy the equation. That means the left side of the equation equals the right side of the equation. An ordered pair of real numbers x, y is said to satisfy the equation when substitution of the x coordinate and the y coordinate into the equation makes it a true statement. And again, true statement means left side equals the right side. And here are some examples. So here they have the ordered pair 1, 8, and they have the equation y equals 2x plus 6. It says, well, it tells us it's a solution, but how would we do that? We would substitute the x coordinate in for x, and we'll substitute the y coordinate in for y. So we will have 8. Does that equal 2 times 1 plus 6? So we have 8 on the left side, and on the right side we have 8. So we get 8 equals 8. Therefore, this is a solution. However, if we did the point 2, 3, plug the 3 in, this time for y, and 2 in for x, we will have 3. Does that equal 2 times 2 plus 6? Well, on the left side is still 3, but on the right side now it's 10. They are not equal. Therefore, 2, 3 is not a solution. So in order for an ordered pair to be a solution, the left side of the equation must equal the right side of the equation when you plug this ordered pair in for x and y. Alright, so example. It says, given the equation 2x plus 3y equals 18, determine if the ordered pair 3, 4 is a solution to the equation. So we have 2x plus 3y equals 18. And we need to determine if 3, 4 is a solution. So remember, the 3 is the x and the 4 is y. So everywhere you see an x, you're going to put a 3, and everywhere you see a y, you're going to put a 4. So this is 2 times 3 plus 3 times 4. Does that equal 18? So we have 6 plus 12, which is 18. So 18 equals 18. So the answer is yes. 3, 4 is a solution. All right, objective 4. Find solutions of an equation in two variables. So not only are you going to find one solution, you're going to find many solutions. So it says find 5 solutions of y equals 3x plus 2, selecting integers for x starting at -2 and ending at 2. So remember, a solution is an ordered pair x, y, such that when you plug the x coordinate in for x and the y coordinate in for y, the left side equals the right side. So we're going to make a table. So you have x, x, and then you have your y. If you want to, you can write your equation. You can write y equals 3x plus 2 right here. Okay, so they say start at -2 and end at +2, and these are integers. So -2, -1, 0, 1, 2. And what we're going to do, one x at a time, we're going to replace it into our equation and solve for our y. So we have y equals 3 times -2 plus 2, which is -6, plus 2, which is -4. So we have the point -2 comma, negative 4. We do the same thing when x is negative 1. And we get y to be negative 1. And then go ahead and continue your table. And you get the following 5 points. So we have negative 2, negative 4, negative 1, comma, negative 1, 0, comma, 2, 1, comma, 5, and 2, comma, 8. And if you were to take any one of these points and plug them into the equation, you will get the left side to equal the right side. Can you find more solutions? Yes, all you gotta do is pick more x values. All right, objective 5, using the point plotting to graph linear equations. So now we're going to plot those 5 solutions. So it says graph the equation y equals 2x. So the first thing you need to do is make an x, y table. So again, let's pick some x values. I'm going to pick negative 1, 0, 1. And then you're going to plug it into your equation to find your y. So we have y equals 2 times negative 1, which is negative 2. So we have the point negative 1, negative 2. And then we have y equals 2 times 0, which is 0. So we have the point 0, 0. And then we have y equals 2 times 1, which is 2. So we have the point 1, comma, 2. And then step 2 is to plot the points. So negative 1, comma, negative 2. That means if I start at the origin, go 1 to the left, and then down 2. And then 0, 0, well, that's still at the origin. And then 1, comma, 2. 1 to the right, 2 up. Connect your points, extend out your line, and put on arrows. And that is the graph for y equals 2x. All right, so another one, we have y equals 1/2 x plus 2. So we're going to do the same thing. So we're going to start by making our xy table. This time, notice that we have a fraction multiplying our x, which means when we pick our x values, we should pick ones that are multiples of 2 in order for our y not to be a fraction. So for example, we can pick negative 2, 0, and positive 2. And if we plug these values in, I'll show you what happens. We have y equals 1/2 times negative 2 plus 2, which is negative 1 plus 2. The fraction clears out, and y is positive 1. So we have the point negative 2, positive 1. And then we're going to have y equals 1/2 times 0 plus 2, which means y is 2. So we have the point 0, comma, 2. And then we have y equals 1/2 times 2 plus 2, which is 3. So we have the point 2, comma, 3. And then step 2 is to go ahead and plot these points. So we have negative 2, comma, 1. So 2 over to the left, 1 up. And then we have the point 0, comma, 2. So no direction in x I'm sorry, don't move in the X direction, but go up 2. Then we have the point 2, 3. So 2 to the right, 3 up. Once you have your points, go ahead and connect them, extend out your line, and put on arrows. Okay, so this concludes our video for 3.1. Please email me if you have any questions.